Lesson 18.4, Task 3. Solve real-world quadratic equations using any method. All right, a video game deployment company plans to release a new video game. The company uses a quadratic model to predict the future revenue, R, in millions of dollars, based on the number V in tens of thousands of video games sold. The total cost, C, for developing the game is in millions of dollars. The profit, P, is the difference of the revenue and the cost. How many video games does the company need to sell in order to break even? That is, make a profit of 0. All right, so to break even means a profit of 0, which means their costs are not more than what they're bringing in. So that's kind of a break even. It's just a term they use for that. All right, so R of V equals 0.02 V squared plus 0.5 V. C of V equals 17. All right, so it's saying that the profit is equal to the revenue minus the cost. So they're giving us the equation for revenue. That's the money that we're bringing in off what we sell the video games for. And then this is the cost per video game. So it looks like each video game costs $17. All right, so again, the profit is the revenue minus the cost. So it says write the equation. Use the given model to write the equation for the situation. So they're taking R of V, which is given here, and then minus C of V, which is 17. So R of V minus C of V equals your profit, and we want it to break even. So again, it says that we want it to equal 0. All right, so it says, what does the number 17 represent in the equation for the situation? So the future revenue in millions of dollars, so it doesn't represent revenue. The number of video games sold in tens of thousands. The cost of developing the game in millions of dollars. All right, so again, C of V is the cost of developing the game. So C of V here was the cost. And if you go back up here, it says the total cost, C, of developing games in millions of dollars. All right, so it says solve the equation. All right, so if you look, we do have a quadratic equation here. We have a V squared plus V plus or minus C equals 0. So we got an A, B, and a C. In this case, we're just using the variable V, but it's still a quadratic equation because we have a V squared. All right, so we've got A, B, and C. We're going to plug it into the quadratic formula and then simplify. So they simplified the discriminant first. And then once you do that, then you just simplify. It looks like they've plugged it in and found an approximate number here. So we've got V is approximately 19.22 or approximately negative 44.22. All right, so it says choose the statements to explain why using the quadratic formula is a good method for solving this equation. All right, completing the square would be difficult because the coefficients are decimals, which means it would be hard to get a squared term for your A squared. So decimals would make it hard to have a perfect square. So there is a blank term, so square roots cannot be used. All right, because there's a middle term, again, if there's a middle term, you can't use square roots. So the quadratic expression is not factorable. So using the quadratic formula is the best method. So this basically is just eliminating. This is telling why the other methods are not good, why we need to go to the quadratic formula. All right, interpret any solutions, then check by graphing. All right, so the negative solution does not make sense in this context because the company cannot sell a negative number of video games. The model predicts that the company will break even if approximately 192,200 video games are sold. The graph supports this. So if you graph P of V. This is your equation for profit, okay? And then we want to know when it's going to hit 0 or break even. This is your x-intercept. So you can see this is your 0 here on the y-axis, so this would be your x-intercept. So it says approximately 10,000 video games. If you round that up, it'd be approximately 10,000 video games need to be sold for them to break even or just start to make a profit. All right, that's all for task 3. If you have any questions, please let me know. Lesson 18.4, and we're going to talk about a couple problems just because I want to make sure that you understand. This whole lesson is about choosing the appropriate method, choosing the best method, which typically means choosing the fastest method to solve. Now, why is it important to solve quickly? Well, when you get to time tests like the ACT, so your junior year when you take the ACT, or whenever you decide to take it, but for the math part of the ACT, there are 60 questions in 60 minutes. And even for me, that's difficult to do. So you want to always be able to determine what method is the quickest when solving an equation. All right, so it says state the method of solving that requires the fewest steps for each quadratic equation. So we have graphing, we've done factoring, we've used square roots, we have completed the square, and we've used the quadratic formula. So there's lots of ways to solve these problems. And what we want to do today is just identify the way that's going to be the quickest for each problem. All right, so we're going to look at question 1, x squared minus 3x minus 10. These numbers are relatively small, and I want to see if I can factor this. If I can factor it, set the factors equal to 0 and solve, bam, I'm done. So how do I factor? A times C, add to get B. So what multiplies to give me negative 10? 1 and 10, and 2 and 5. Okay, 2 and 5 are 3 apart. So this one will factor. So for number 1, quickly I can determine the quickest way to solve this is by factoring. Then I can solve it and be done. So let's go ahead and solve number 1. X squared minus 3x minus 10 equals 0. All right, so if I'm going to factor this, I'm going to have x times x, remember, is x squared. And I said 2 and 5. I need to multiply to get a negative number, and I need my bigger number to be negative. So then I set my factors equal to 0. And I solve. So those are my 2 solutions when I factor. Remember too, you can always quickly check and make sure you factored correctly. X times x is x squared. Minus 5x plus 2x is negative 3 in the middle. 2 times negative 5 is negative 10. All right, so those are my 2 solutions for number 1. Let's see, so I'm going to put this would be factoring. All right, so number 2 over here, I see that there's no linear term and the constant term's already over here. So the quickest way for this is going to be square root. So I'm going to do square root. And that just means I'm going to solve for x, just like it is. So it's already only has one variable. Quickly, I can divide by negative 5. X squared equals, divide 30 by 5, I get 6. I'm going to take the square root of both sides. X equals plus or minus the square root of 6. So that's a perfect square. Take it, but 2 times 3, neither one's a perfect square, so you are done at that point. All right, number 3, I've got 2x squared minus 3x minus 7. If I try to factor it, 2 times 7 is 14. Is there a difference of 3 there? So 14 is either 1 and 14 or 2 and 7. Neither are 3 apart. So for this one, I'm going to use quadratic formula. because this is not a perfect square, okay? So quadratic formula, remember, A, B, and C. So I've got A equals 2, B is negative 3, C is negative 7. So I'm going to have X equals negative B, negative 3 is positive 3, plus or minus the square root, B squared minus 4 times A times C, all over 2A. And then you would simplify that, and that would be your solutions for number 3. All right, since we're looking for just the method here, I'm going to move on to the next one. So this one has a perfect square, and it's already has the constant term moved over. So I would think this one, the best method or the quickest with the fewest steps, would be completing the square. All right, and just to get you started on this one, we have 4x squared plus 16x. So we're going to complete the square, which means we're going to add the number here that makes that a perfect square. So we're going to have 3 plus blank as well. So whatever we add here has to also be added to the other side. So what are we going to add? So we're going to do b squared. I'm going to come up here and do b squared over 4a. So let's see. If I get my calculator here, b squared is 256 because I'm doing 16 squared over 4 times a is 4. So 256 divided by 16. So the number that goes in here would be 16. And then I would rewrite this as 2x plus 4 squared using my perfect square trinomial that I can factor now. And then 16 and 3 make 19. Take the square root of both sides and finish it from there. So again, it is handy to be able to choose which method to use, and it is handy to know different methods because sometimes different things work different or better for different equations. Now, all of these you could graph and check to see if your solutions are correct. And if you have any questions on any of these methods, please let me know.